Hi everybody, Mr. Garrett here, and we're going to go over 3.2, which is talking about dividing polynomials, the factor and remainder theorem. First thing we need to know about dividing polynomials is how to do long division. And so as a quick recap from third grade or so, we're going to do some quick long division. So when we're doing long division, we say, how many times does 3 go into 2? Well, 3 doesn't go into 2, so we say, how many times does 3 go into 28? And 3 goes into 28 9 times. We multiply the 9 times the 3 to get 27, and then we subtract, bringing down the 1, and then we bring down the 7 as well. Say, how many times does 3 go into 17? That happens 5 times. 5 times 3 is 15. Subtract, and you can see this pattern. We bring down the 5. How many times does 3 go into 25? 8 times. 8 times 3 is 24. Subtract, get the 1, bring down the 6. How many times does 3 go into 16? 5 times. 3 times 5 is 15. Subtract, and we get a remainder of 1. Now, back in third grade, we'd put remainder 1. Then in fourth grade, when you learned about fractions, you wouldn't say that. You would say, and 1/3. And so this is how we're going to usually express our remainder when we're dealing with polynomial division. Over here, we have the same idea. We have this polynomial x cubed minus x squared minus 2x plus 8. And we're going to divide that by x plus 2. Now, the thing about polynomial division is we only focus on the first terms, and then we worry about the rest as it comes through. So what times x is x cubed? Well, x squared times x is x cubed. Now, when I multiply, I need to multiply both by the x and the 2. So x squared times x is x cubed. X squared times 2 is 2x squared. Now, this is where it gets a little tricky. When we subtract it over here, we're subtracting numbers. That's easy. Now we're subtracting polynomials. And so I'm going to just change my signs and add. And so x cubed and negative x cubed is 0. Negative x squared and negative 2x squared is negative 3x squared. Now I bring down the negative 2x. And again, I look at the first terms. How many times does x go into negative 3x squared? Well, it goes in negative 3x times, because negative 3x times x is negative 3x squared, and negative 3x times 2 is negative 6x. To subtract, I change my signs and add, and that gives me 0 plus 4x. Then I have bring down the 8, and I say, how many times does x go into 4x? Well, that happens 4 times. 4 times x is 4x. 4 times 2 is 8. And then what happens when I subtract or change the signs and add? I get 0 as a remainder, which is really, really good. Okay? If I would have gotten a number here, say 2, what I would have probably done is just said 2 over x plus 2, because that's our divisor. And so here I get 0, so I don't need to put anything there. And this here is my quotient. This is my dividend, and this is my divisor. What I divide by is my divisor, what my answer is my quotient, and what my remainder is my remainder. Now, we can do the same thing through synthetic division if we're dividing by x plus a number or x minus a number. In this case, we're dividing by x plus 2, and so I can put negative 2, or the opposite of this, in the box. And so we put negative 2 in the box. We write down the coefficients. In this case, we're not missing any coefficients, but if we were, we would put down 0. Skip a line, draw a line, bring down the first term. Negative 2 times 1 is negative 2. Negative 1 and negative 2 is negative 3. I add down. I multiply back up. Negative 2 times negative 3 is a positive 6. Negative 2 plus positive 6 is positive 4. And then negative 2 times 4 is negative 8. I get a 0 here, and that's my remainder. And because this was x cubed from right here, when I divide by x minus negative 2 or x plus 2, this becomes x squared. This was the x squared term, now it's our x term. This was our x term, now it's our constant term. This was our constant, now it's our remainder. And so I could write out our solution of x cubed minus x squared minus 2x plus 8 divided by x plus 2 is equal to x squared minus 3x plus 4 with no remainder, or a remainder of 0. So this is our dividend, this is our divisor, this is our quotient. We have a remainder of 0, so I just put plus 0. Why is this important? Well, it's important because we can identify the remainder very easily when we divide by x minus c by plugging in c. If you remember last year in Algebra 2, we talked about synthetic substitution. And when we talk about synthetic substitution, it looked a lot like synthetic division. This here was what we plugged in, and this was what we got out. Well, what do you know? This is what we plug in, and this is now our remainder. And so to identify what f of negative 4 is, or what this would be, we would simply find the remainder using f of negative 4, and we could do that synthetically. So there's negative 4, 3, 4, 5, 3. We're not missing any terms. Skip a line, draw a line, bring down the 3. Negative 4 times 3 is negative 12. 4 plus negative 12 is negative 8. Negative 4 and negative 8 is 32. That's 37 when I add down. And that right there is negative 148. If I add, I get negative 145. If you want, you can try doing synthetic or long division with this, and you will see that you get the same exact remainder of negative 145. But that is essentially when you take this and divide it by x plus 4. The remainder is negative 145. Likewise, we know that the factor theorem tells us that if c is a 0, x minus c is a factor. And if x minus c is a factor, f of c is 0. Why do we need to know this? Well, it's helpful because if I know this polynomial and I know negative 1 is a 0, then I automatically know that x minus negative 1, which is also x plus 1, is a factor. Why is that helpful? Well, I know then that if I want to break this down, I can break it down into x plus 1 times another factor. How do I figure out what goes into this factor? Well, if I told you 3 was a factor of 6, how do I figure out what goes here? Well, 6 divided by 3 is equal to 2, and that's why 2 goes there. So to figure out what goes here, I need to divide 15x cubed plus 14x squared minus 3x minus 2 by x plus 1. Conveniently, we can use synthetic division. 15, 14, negative 3, and negative 2. And I should get 0 for my remainder because it is a 0. So negative 1 times 15 is negative 15. Add, I get negative 1. Multiply up, I get 1. That's negative 2. That's 2. That's 0. That's good. And we now know that negative 1 was a 0 because when we plugged it in, we get 0. So that's a remainder. We also know that 15x squared minus x minus 2 is our other factor. And so this right here, we would look to see, can it be factored even further? Let's see, that'd be negative 30, negative 6 and 5. So yeah, that could be factored further. That would be x plus 1 and 5x and 3x. This would be negative 2. This would be positive 1. And these are our factors. To find the other zeros, set these factors equal to 0, and that would tell us all the zeros of the polynomial. And so the factor theorem helps us out that way. Here's one other example. If 3 is a 0, x minus 3 is a factor. So what I'm going to do is I'm going to take this and I'm going to say, all right, well, let's put x minus 3 as a factor, and let's figure out what goes there. So synthetic division, 3, 2, negative 3, negative 11, and 6. Bring down the 2. 3 times 2 is 6. Add those down. 9, negative 2, negative 6. We get a remainder of 0, which is good. And I know that in here it goes 2x squared plus 3x minus 2. Can I factor that? Negative 4. Let's go forward. Negative 1. Yep, we can. So we're going to say x minus 3. We're going to say 2x and x. We're going to call this positive 2 and negative 1. These are my factors now. And when these are my factors, oh wait, hold on, that did not work. Oh no, that works, my bad. When we have these as factors, we know x minus 3 equals 0. We know 2x minus 1 equals 0. And we know x plus 2 equals 0, which allows us to say x equals negative 2. 2x equals 1, x equals 1/2, and x equals 3. So my zeros are negative 2, 1/2, and 3. And that's the usefulness of the factor theorem. So I hope that helped, and good luck.